Hello guys, welcome back to Khaliltronics. In today's video, we are going to see special types of integration known as integration by fact. So in calculus and more generally in mathematics analysis, integration by fact is referred to the specific integration method for a product function. So it's a specific for what product function, like when you have two functions, like say exponential of x, and then you have what x raised to the power of what 4, or sine x, or any other function. So it's just the product. If you have x raised to the power of 4 and then times exponential or sine or transcendental function, so it's just what product rule. If you have such integration, x is a function and the sine of x is another function, or let's say exponential. So in this case it's going to be what product rule. So the product rule for integration is known as what integration by fact. So you're going to take this one and this one at the same time and solve it. So integration by fact refers to the method for product of a function based on integration of the product and their derivative and then antiderivatives. It's frequently used to transform antiderivatives, that is this, let's say this, antiderivatives of the product of a function into an antiderivative for which the solution can be easily found. This rule is taught as an integral version for the product rule of differentiation, as I said. So it's just like to find if you have y is equal to let's say x raised to the power 4 sine x. So in this case, if you want to find the derivative, that's dy dx, so it's just what product rule, to use product like x raised to the power 4 and then sine x. So in this case you have to apply what product rule. But in integration, if you have such this x raised to the power 4 sine x, so you are what to apply what integration by what by fact. So the formula is given as the integral of ub is equal to what? Integral of ub, that's this, integral of ub is equivalent to ub minus integral of b du. So the formula is given, it's just need to compute the integral. So, and then it's also discovered by Vogel-Taylor in 1715. So we are going to take start from the simplest question and then proceed to the difficult one. So since the formula is given, we are going to let's say we are going to take question 1, most easiest, like when you have x exponential of x. So if you want to integrate this function, this is x function and then this is the exponential function, so we have to apply, it's like product rule, so we have to apply integration by fact. Okay, so what you need to do is just to use the formula. So actually the question is this, like let's say question 1, let's see, the function is like this. So it's to find the integral of x and then multiply by exponential of x. So all you need to do is to come here and say, since here is u and here is v, so you can just you can say let the x to be equal to u, so you can say let u to be equal to what x, and then let dv, this dv to be equal to what exponential of this of x. So you can also say dv to be equal to what exponential of x. For the first time we say x to be equal to what u to be equal to what x, and then this dv to be equal to what exponential of x. So we have u is equal to x and then dv is equal to what exponential of x. And then just look at your parameters. Since we have u we have the b, so we need the u also, b and then v du. So you have to find it. So firstly, we have u, we have the v. We have u already, we have u here. So we have a dv, we already have it, so we need v. So to get b, you have to integrate this. Since here is dv, if you integrate this function, it will become b. So if you integrate this, we say dv, let's take this, the function first, is equal to what? Exponential of x. So if you integrate both sides, you will have what? Integral goes with derivative, then we have b is equal to what? Integral of e to the x, which is equal to what? Integral of e to the x is equal to e to the x, is the same. So we have what? U as well as v. We have v. So here is another v, we have it. What we don't have is what? The u. So how can we find the u? So remember, here we have what? U. So if we differentiate this with respect to x, we'll find what? The u. Then we can say the u with respect to what? X is equal to what? If we differentiate this, we will have what? 1. So if you cross multiply, we will make the what? The u to be subject. Then we can say the u is equal to what? 1 multiplied by what? Dx. So we have the u, we have v, so we have all the parameter. What is left is to just what? Substitute. So we can say integrate using the formula, right? So we have integral of u, we have u as x, so we have x, and then dv, we have db as what? Exponential of x, and then it's equal to, so since this is what we are looking, so it's goes to go, then it's equivalent to uv. We have we have u as x, we have u as x, so you just put it, and then we have what? B. Let's take our v. Our v is equivalent to exponential of x, so we just put it, and then minus integral of v. V is what? Exponential of x times du. Our du is 1 dx, so we have 1 multiplied by dx. So we just, since this is what we are looking, so no need to consider this. We can say we have x exponential of x minus integral of 1 times e to the x is just e to the x, so we have integral of what? E to the x with respect to what? X times dx, sorry. So we still have x exponential of x minus what? Integral of exponential of x, integral of e to the x is just e to the x, so we'll have e to the x with respect to x is e to the x. So finally we have integral of what? X e to the x is equal to what? X e to the x minus what? Exponential of x. So this is the final solution of this. So by using this formula, I will be able to find this. So let's take another question and see how this works. Remember, this is the simplest question. We'll take another question. In some question, you will come across with maybe one question that you need to do integration by part like 2 times or 3 times for you to get what? To get the final results. So let's see how does this work. So, and then actually, and also if you have like this, let's say if you have this, let's say x raised to power 4 cos x is also what? Integration by part. If you have x plus x squared plus what? 2x plus 9, and then what? Sine of x is also what? Integration by part. So it's just apply integration by part and then proceed. So let's take another question and see. Okay. So we have to take another questions. Let's say let's take another questions. Okay, so let's take another question and see. My pen is fluctuating. Okay, so let's see question 2, example 2. So we have to integrate what, let's say we have function as x squared e to the x also. So we have to integrate this. If you by now looking, this is what integration by part is, just like product of the integration. So one thing you need to understand, if you remember, our formula is what, integral of what u dv is equal to ub minus integral of what b du. Okay, so all you need to understand, like the first, if you want to let, like here you know, is, let's say u, or here it can be db. So you have to be very careful if you want your calculation to be more easier. You have to be very careful if you want to if you want to come across with lettering. So you know, there is what we call transcendental functions, such as what, the function that, such function when you differentiate it will not easily to go zero, it will keep increasing. Like let's see, if you have y, let's see, if you differentiate it, let's see, you have dy by dx. So such function that is transcendental, transcendental function. So such a exponential of x, sine x, cos x, tangent x, and many more. So such function are called transcendental function. Remember, if you integrate this, no matter how, this cannot be equal to 0, no matter how many times you differentiate it. Like if you differentiate this, let's see, if you have, let's see, 2x, if you differentiate this, it will become what, 1 over 2 exponential of what, 2x. If you differentiate again, 1 over 4 exponential of 2x. If you differentiate again, 1 over what, h exponential of what, 2x raised power of what, 2 to the 2x, 8 to the 2x. So it will keep increasing. Likewise for sine, if you differentiate sine, it become what, minus cos. And then if you differentiate again, differential of cos is what, is just sine, it become what, minus sine. If you differentiate minus sine, is minus cos, then minus is become what, cos. So this one is keep increasing. Likewise for cos, it would what, remain the same, it will keep interchanging. For tan, it will keep interchanging. But if you have x, such, let's say, even if you have x raised power of what, let's say 5, so if you differentiate this, it will become what, 5 what, x raised power 4. If you differentiate again, it will become what, 20 what, x raised power of what, 3. If you differentiate again, it will become what, it keep reducing, it will become what, 60 x squared. If you differentiate again, it will become what, 120 x, right? It will keep what, decreasing. If you differentiate this, since here we have 1, if you differentiate, you have the coefficient 120. If you differentiate again, it will become what, 0. So x function is going, if you differentiate, f function is going to be equal to what, 0, while the transcendental function, whether you integrate or differentiate, what, it will not going to be equal to what, 0, unless you have something like x cos 0, it will become what, 0, or sine 0. So basically, the reason why I used to tell you this is when it comes across to what, lettering. So if you have a transcendental function like this, you know that from here, this exponent is a transcendental function. So you can say u to be equal to what, x square, because if you what say du by dx, like you are trying to differentiate this, so this function you are differentiating it, then become 2x square. And then this you say let dv to be equal to what, exponential of x, and then you are trying to find b. If you integrate v to the x, it will become what, exponential of s. So all you need to understand here is that don't come and take what, exponential of x to what, to integrate it. You are to what, to put it the place where you can what, differentiate it, so that it will what, goes to what, 0. The reason why in some question you can find out that you have to what, integrate by, you have to do integration by part like 4 times, 3 times, 6 times, is depend on the power of the x. So but if you choose the correct place, if you choose the good method, like if you put the x variable in a what, differential site, it will what, become more easier than the integral part. So when we come to shortcut method for partial fraction for integration by part, I'll show you how these things work. So that is one procedure or one method that you'll be able to solve any kind of integration by part in just 1 minute. So it's just like normal procedure, but you have to understand the concept first. So let's proceed with what we are trying to continue. So I hope you got it. So if you have such function, like even if you have, let's see, exponential of integral of x, let's see, integral of exponential of x, then x square. So don't come and say let u to be equal to this and let dv to be equal to this. You can change it to be equal to what, x square e to the x, and say let what, x square to be equal to u, and then exponential of what, to be equal to dv. So all the thing that I explained is to just make what, the thing that has x to be in u. Don't put it on what, the u component. So it's just like normal procedure. Just take this one, x component to be equal to what, u, and then any transcendental function, just put it at what, as the u component. Let's see, sine or cosine. The process is very easy, but you have to understand this. That is why I take much time to explain. So let's proceed. So the question is very simple. The question is very simple. We are to integrate x, let's say is what, e to the x, what, x square. So we say we can change this to be equal to what, x square e to the what, x is all the same. So we can put this to be equal to u. So we can say let's u to be equal to what, the first one, which is x square, and let the what, du to be equal to what, exponential of x. So we let this to be equal to what, u, and then this to be equal to what, du. So we have u, we have db, we have u also, we don't have b. So if you here is dv, I mean we don't have b. So if you integrate this, we can see integral both sides, we can have integral of e to the x. So differential goes with integral, b is equal to integral of e to the x, which is also e to the x. And then since we got b and then we got u, we don't have we have b also, but we don't have the u. So we can differentiate this. We can say du with respect to x is equal to what, 2x, and then we can make du to be subject, since it is the one that we are looking. So we can say du is equal to what, 2x what, dx. So since we have all the parameters, we can put it on our formula. So we can say integral of u db, we have u as what, x square, and we have dv is equal to what, e to the x, is equal to, we have what, ub, let's multiply ub, we have u as what, x square, and we have what, b, here we have b as what, e to the x, and then minus integral of b, we have b also as e to the x, and then times what, du, we have du as 2x dx, multiply by what, 2x dx. So this become e to the x square e to the x minus integral of what, 2x minus integral of what, 2x e to the x what, dx. So as you see here, supposed to be the final answer, since we have what, we have substitute, but unfortunately here is also integration by part. You see here there is no integration, but here there is integration, and then to do so, to integrate this, it is also what, integration by part. So you have to what, keep this aside, and then take this one, the whole this one, and do the integration by part again. So you, as you see, this is how the thing is going. You find across with a question that you have to do integration by part like 3 times or 4 times. So it's based on the question, and then it's based on the power of x. Here is x square e to the x. So we will keep this aside and take this one. This is our main target. So we have what, integral of 2x exponential of x dx. So we can also say let this one to be equal to what, u, and then the other one to be equal to dx. So we can say let u to be equal to what, 2x, and then the v to be equal to what, exponential of x. Okay, so as we already know from our formula, we need v, so we integrate this, that's integral to both sides. Here we have integral of dv, this go with this, then we have b is equal to integral of e to the x, which is equal to what, e to the x, and then we still need what, at u, so we differentiate this. You can say dv with respect to what, dx is equal to what, yeah, if we differentiate we have to, and then making du to be subject, you have to multiply by what, dx. So you just have to put it on the formula, which is quite easy, and then complete the questions. So we have u dv is equal to ub minus integral of what, b du. So we have what, integral of u dv, which is what, 2x exponential of x is equal to ub, we have u as 2x, we have b as what, e to the x, and then minus integral of v, we have v as e to the x also, and then we have du, we have du as 2 dx. Our u is this, 2 dx. So we can simplify the questions, which is going to be equal to 2x exponential of x minus what, integral of 2 e to the x dx. So here it's become 2x e to the x minus, so as you see here is just constant times exponential of x, there is no variable of x. Then we can just apply normal integration. So we can see integral of this is just what, 2 e to the x, and then we'll arrange it, which is to become what, 2x e to the x minus 2 e to the x. So we'll take our first our previous solution, which is what, which is which is this, which is what integral of what x square e to the x is equal to this is it, yeah, this is it, and then x square e to the x minus the whole this minus the whole this. So this is what we get, and this is equal to what, let's see, so we have what, we have x square e to the x minus, then we have before we have, let's see, integral of 2x e to the x dx, but we got this as what equal to this, so we can substitute. We will have x square, we have x square e to the x minus, in bracket we have what, 2x e to the x minus what, 2x, sorry, 2 is just 2 exponential of x. So we can open a parenthesis to become equal to x square e to the x minus 2x e to the x, then minus plus 2x, sorry, I mean 2e to the x. So this is the final solution. So as you see, this question e to the x is what you have to do integration by part twice. So if you have this x for 3 e to the x, you have to do 3 times. If you have integral of x raised for 5 e to the x, you have to do it what, 5 times. So but luckily we have a special method for solving integration by part easily. So I'm going to show you how the procedure is working, but firstly let me do it in short here, so that I will have one video showing you how to solve shortcut. So firstly, let's use DI method by finding this solution of this problem. So let's say here you have D and then I. The process is just DI process. So you have here D, which is differentiation, and you have here which is what, integration. Here is differentiation. So let's say D and I. So as I already explained, transcendental function, that's the one that has cost sign. So just put it as integration part. So let's see, the question is what is x square e to the x, right? As integral, we have to find this. So we can put this one that is transcendental in what, integration part. So we have this e to the x, and then this one normal plus x at what, differential sign. So we have, let's say, plus minus like this, it will go in forever. So here if we differentiate this function, since here is in differential part, we differentiate this, we have what, 2x, right? If you differentiate this again, we'll have what, 2. If we differentiate 2 again, we have what, 0. So if you come 0, just stop. So here this part, if you integrate this, you have e to the x also. If you integrate this, e to the x. If you integrate this, e to the x. So we'll do like diagonal cross. We'll just do this. We'll just do this. We'll also do this. But this plus minus, it has to be what, included. So we can say this, whatever you have this, whatever you have at the coefficient of x, what you have ever as the coefficient of this exponential is have to be considered. So this here we have plus, so you can say plus. Here we have plus as x square, plus times plus is plus. Here we have plus at the exponent of x, then we have plus. So you can say plus 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 is plus, then we have plus. Then x square times e to the x, we have what? X square e to the x. And then for this one, we can say minus times plus. Here we have plus, remember here we have plus, so here you can see minus times plus is minus, then minus times plus that we have here is still minus, so we can say minus, then 2x times exponential of x e to the x, then we have 2x e to the what? X. Then for this one, we have plus here, here we have plus, here we have plus also, then we can say plus times plus times plus, we have plus. Then 2 times e to the x, we have 2e to the what? X. For here we have 0, so we can stop. So the final answer will be x square e to the what? X minus 2x e to the x plus what? 2e to the x. So as you see, this is equivalent to this. So I'm going to have a video on this, how to solve this using shortcut. So thank you for watching. Don't forget to subscribe, give a like and comment. Thank you.